Hi dear students, today we are going to study the topic about limit, okay? That how we find the limit and how we calculate limit, and what is the meaning of limit by graphical method also. So here is the notation of limit. So let me just change this color because it is okay. So here is some notation for limit. You can observe that the notation of limit is denoted by this, okay? It means that it denotes that limit of a function fx at x tending to a. Okay, this denotes this. And what is the meaning of this? It means that when our x approaches to a, when our x approaches to a, then fx approaches to fa. Okay, this is the meaning of this notation. Now, by the graph, let's observe. By the graph, you can observe that if this is the given our graph, this is a graph of fx, okay, and we are trying to find the limit at x tending to a, okay. That means whenever we are approaching along the x-axis to the point x is equal to a, our fx, that means our function value, approaches to where? It approaches to fa. You can observe through the graph, whenever we are approaching to a, our function f approaches to fa. And when we are approaching from the behind of a, that means a minus along a minus h, where h is nothing but it is a greater than 0 and it is a very small value, okay, small value through which we approach, okay. This is a very small value through which we are approaching toward a, then our graph is approaching to fa. What is the meaning of approach here? Sometimes students get confused. Approach means as we just move toward our a, okay. That means in onto x when we move toward a, our the value of graph approaches nearly to a. You can observe that this line what we have drawn now, it is approaching toward nearly a, fa I mean, okay. So similarly, when we approach from the this value from a plus a toward a, that means from right hand side when we are approaching, then this line you can observe that this will again approach to fa, okay. The value of function graph, that means the value of fx approaches again to nearly a. So in this way, this when we are approaching along the a minus h, it is called the left hand limit, and when we are approaching from the a plus a, that means the right hand side of a, it is called the right hand limit, okay. I'm going to just explain it also onto the next page, okay. So I hope you understand this graph. This graph represents the meaning of a limit. Onto the next page, I have just told you that left hand limit. As I told you that when we are approaching along the this limit a minus h, okay, when we are approaching to the a minus h, just wait, okay, when we are approaching to the a minus h, it is called the left hand limit. You can observe left hand limit. When our h is going to 0, as our h goes to 0, this will go to fa. That means it will go to this value. So the function will go to fa. Okay. So this is our left hand limit. And on the right hand limit, this is limit is evaluated when h is going to 0 from the a plus h side. Okay. A plus h side means what? From the right hand side of a. From this. Okay. When from this side we approaches to a, again our graph goes to fa. So this is called the left hand limit and this is called the right hand limit. You can observe there are the two notations for the left hand limit. For evaluating we use this notation. Okay. To left and right limit can be evaluated by using this notation. Now, in case when our left and right hand limit equal, in that case only our limit of the function exists. Okay. We will later discuss some results in which you can observe there are some examples of examples means there are some functions for which limit does not exist. I will explain you, and in that case you will observe that these two are not equal. So let's move to that. Here I'm going to discuss that example in which limit is not existing. When not exist our limit, okay, limit, our limit not exist. Okay, so I have taken an example. I have taken a function fx is equal to mod x upon my x. Okay. So when you draw the graph of the mod x upon my x, what is the mod x upon my x? Let me just write the functions for you so that you can understand it clearly. The value of this function is 1 when our x is greater than 0. Okay. And it is a minus 1 when our x is less than 1. Sorry. Okay. Less than 1. Sorry, less than or less than 0. Okay, sorry, my pen is not working again. Okay, when the value is x is less than 1, it is a minus 1, and when the value is a greater than 1, it is a 1. Okay, this is a graph of the function you can observe. So we have to find the limit at x equal to 0 actually. Okay, and at a 0 they both can be 1 also, minus 1 also. It depends from along which line we are approaching toward that. It depends only onto that. Okay, so let's find that the equalities also holds with those with both, I mean. Okay, so let's observe. So you can observe when we are approaching from the left hand side, that means from 0 minus h, meaning we are approaching toward the 0 onto the x-axis, you can observe our function is going to minus 1, as we have drawn the graph of this function, as I have explained you the function here. So this approaches to the minus 1 here, and when we are approaching from the right hand side to the point 0, that means along 0 plus h. Okay, you can observe our function's value is plus ka 1. So it is a minus 1 and it is a plus 1. So here is a left hand limit by the definition we have calculated, we get minus ka 1. And the right hand limit by the definition we have calculated, we get plus ka 1. You can just see the calculations also. 0 minus h here. So in place of fx, x here, we have here minus ka h. So we will put inside the minus h, and here we have minus h. Modulus will get plus, and minus h is in the division part. So when you divide, you get minus ka 1. Okay. So here we have minus ka 1 limit in the left hand side. Similarly, in the right hand side, here we have 0 plus h. So in place of x, in this case, we have plus ka h. Put plus ka x here and also h here. So when you divide, we get plus ka 1 here. So the limit onto the right hand side is 1. You can observe here left and right limit are not equal. And as previously I have told you, whether these two are not equal, we say limit does not exist. That's why in this example, limit of fx as x tending to 0 is not existing. Okay, because the left and right are not equal limits. Now let's move to another example in which limit exists. Now we are going to discuss example in which limit is existing. Okay, so we have taken a function fx is equal to x, and we have to find the limit of fx when x is approaching to 2. Okay, so let's draw the graph of fx. We have drawn the graph of fx is equal to x, that is nothing but this graph. Okay, so this is a point x is equal to 2, and as we approaches along the left hand limit, that means what, 2 minus h, we are approaching toward the 2. That means as our h is going to 0, this value will approach where? This value will approach to, but it is approaching from the left hand side. Okay, why left hand side? Because we are subtracting h from 2, as I have explained you previously. So when we approach from the left hand side, by the definition you can observe that this value goes to where? 2 minus h, and as h approaches to 0 in this, we get 2 minus 0, that is, it is going to 2. And in the right hand limit, we are approaching from the right of 2. Okay, right hand 2 means what? 2 plus some h, where as I told you previously, h is greater than 0, but it is a very small value. Okay, so the value 2 plus h, and when we put in the function fx, that is our x, we get here 2 plus h. When h is approaching to 0, again 2 plus 0, that is 2 again. Okay, so we again get 2. So here we can observe that they both are equal, and as I told you previously, when both limits left and right are equal, then we say the function's limit exists at those value at which we are calculating the limit. So we get that limit of fx at 2 is going to or approaching to f2, and where our f2 is nothing but it is equal to 2. Okay, so we get the limit is 2. Here we get the limit is 2. Okay, that's all for today. Have a good day.